Welcome to the next week of this beginner's training course on how to use Houdini's terrain system to make fleshed out environments. Today, we're going to focus on building assets. In this case, we're going to build some trees. The tree that we're going to build is going to be using the Houdini Labs tools, so make sure you have that downloaded and ready to go. And we're going to dig in and go through how do we art direct that, what are some of the things that we come up against that are challenging. It's not the perfect tool. As with all things, there's going to be challenges that we come up against, and we'll work through some of those. On top of that, we're going to talk about getting into how do you build this so it can come into USD, and how do we structure that to make sure that that tool that was built for sops comes in nicely into our USD setup, and we can use the component builder, which is another Houdini kind of asset pipeline pre-setup that we can use as individuals. If you go into a studio, they're going to have their own way of figuring all that stuff out, but for us, we're just using vanilla Houdini, and we're going to use that component builder to start building out this asset. All right, let's get into it. So the goal is to make assets that we can use in our environment. So the first thing that you go to when you're making large outdoor assets are going to be trees. So the first thing that I tend to start with in training people how to make trees is usually conifer trees, right? Evergreen trees, pine trees, fir trees, right? Whatever you want to call them. So there's lots of species. And ideally, we go and we look at online, and we pull reference, and we kind of design a tree based on something that is built in reality. So for this, we're just going to kind of jump in and start. So I'm going to go ahead and create a geometry container here. And I'm going to go ahead and name it. I'm going to name this one fir. So if we go to our internet real quick here, and we go to Google, and we search for a fir tree. Oh, we're in Bing. Thought it looked strange. Fir tree images. This gives us an idea, and you can see there's lots of different species of fir, right? So you could go through and pick one that you're interested in making. I'm going to pick something that's kind of like this. This will be my target. I'll probably make it a little thinner, maybe something around this line. So that's my tree. I can see here that I've got a central line that is my trunk, and then I have branches that are angling up off of that main trunk, and then off of those we have flat, branches kind of branching out to the sides of each one of those. So that's going to be the model that we use to design our tree from. Okay, so let's go ahead and jump back over to Houdini here. So inside my fir tree, if we take a look, and let me back this up, I'm going to be using the lab tools. So if you haven't updated these in a while, update them. I highly recommend just turning these on at the install. The lab tools are great for throwing some things quickly together. By all means, none of these are perfect. Just like nothing in Houdini or any software package is perfect. It's just an approach to try to solve a problem. So it's a great place if you're just learning some things where you're not building out from the start. I have built, I don't know how many tree generators in the past, but this is now a great place to kind of start building something and not have to go through that and kind of build it out so in depth every single time. So, all right, so first thing I'm going to do is I'm going to type in tree, and you're going to see here we have a whole bunch of different tools here. We have a trunk, a controller, a tree hierarchy, which I actually don't think has to do with its tree tools. There's a basic quick tree. There's the branch generator, placer, leaf generator. So we're going to use a couple of these. First, let's look at the basic tree. So if we take a look at our basic tree here, oh, and we're getting an error right from the start. Not enough sources specified. I need to give it a line. So this line is going to be the basis for where our tree grows, this basic tree. So if we look at this, there you go. Here's our basic tree. It's got leaf cards on it. It's got some lines that represent stems, would be my assumption, that you could then, they probably have a P scale to them that you could render. I don't ever really use this system, and I'll show you why. So An average tree, again, you have to kind of figure out scale here because scale matters, right? I'm not going to make one tree that represents a sapling that's also then going to represent my full-grown mature tree. So those are going to be two different things. So I'm going to say this is in meters. So let's say that this tree is going to be, let's say it's 10 meters tall, right? So that's about 30 feet. All right, so there we go. So this quick tree, it's like, awesome, it's great. But there's something weird about this. When we look at this, it's kind of this, you know, it forms a square, a diamond, you know, whatever you want to call it, every time. These main branches that come off are always at 90-degree increments. We can come in here and there's, again, I don't use this tool, so how it branches, I'm sure they give you ways to control it because there's decent you know, variation in the branches themselves, but not in this main. The very first one's going, oh, even that's still 90. That's still 90s. You know, it's just kind of deciding the angle. That's the bend. Those are for leaves. I don't really see the. Yeah. So, again, maybe great for really background stuff, right? Way out over here, you won't ever notice. You won't care. So if you're just trying to quickly throw something together, maybe that does what you want. But I find it always takes this exact shape, and I really don't love this tool. So I'm deleting that. So let's go back and type in tree again, and we have this tree controller, and that's going to be a piece of this system that has been broken into chunks. So we're going to use a trunk generator, we're going to use a branch generator, and we're going to use a lab tree controller. So I'm going to just start dropping this all down, and I'm going to lay down a trunk. And you'll see here if you mouse over these inputs, it tells you what it wants. It wants a curve, and it wants a tree controller. So we'll give it both of those, and we'll take a look. And ta-da! We have a trunk. So right off the bat, there's some things I don't love about it. You know, what trunk ends like that? But the reality is because this is expectant that this is, depending on the type of tree, it doesn't think the trunk is going to go all the way to the top of your canopy. So this is really going to be probably obscured by branches and leaves and things. You can see it's giving us some trying to give us some geometry interest there, and there's a whole bunch of things that control all of this. Now what comes out of this is the mesh, and this comes out as the curve. Why do we want both of those out? Well, the cool thing is this little system in the end will result in a wire system that you could build a rig out of, or for deforming your tree. So you could create, you know, a wind simulation on that. You could run it through Vellum and create some simple, you know, wind animation on your tree. I'm not going to get into that. We're just going to, for now, build a tree. So now I'm going to put down a branch generator. And we'll take a look at what that just does right out of the bat. And okay, we've got the beginnings of a tree. Right, and you can see here from my branch growing out of the very tip top there, it kind of continues out, and we don't have that stump, right, of a top. So let's go ahead and let's look at our tree controller now that we have kind of these two basic pieces placed. Oh, we'll throw one more. We'll throw one more on here. And there we go. So now we've got a tree. Right? And in theory, you're like, yeah, that's great. So how do we control this? Because this definitely does not look like our tree that we want to make here. Okay. So when we look at this, we have these different sections. We have tropism. Tropism is what defines how the tree grows. It's building the rules of the world that allow us to decide, you know, how do the branches come off, the directions they take, is it been affected by wind or seeking out light that's only coming from a certain direction. This is like science. Tropism is science. So you can use this to, you know, start figuring out how you're going to simulate the tree growth. Noise has to do with just procedural noise, and there's primary and secondary, which I always love that. To me, I love having two types of noise, always two levels of noise, 2 or 3 levels of noise. It helps to allow you to have high frequency and then low frequency detail. And it's on the line, which is that part that generates the mesh, and on the mesh itself, right? And we can see here, that's what's really creating this kind of bumpy look to the mesh. If we turn this off, then we'll see we get kind of just perfectly straight tubes, right? And this gives you kind of some geometry deformation, so, which is cool. Pruning, you can make it so if a branch faces a certain way, right, it will prune that branch. So let's see here, if we just kind of start increasing this, you can see branches are going to start dropping off here as we increase this. So anything that's facing down by a certain amount gets pruned off, you know, which is a nice little control there, so you don't have, you know, branches that grow straight down, because you usually don't get that, right? So again, just gives us the ability to kind of control what's happening in our tree. Now, the thing with this is it doesn't replace it with a new branch growing from that point following a different set of rules. It just culls it off. So you can end up with fairly sparse trees using this as a rule, right? But this looks less realistic to me, depending on the species of tree. But, you know, this is very strange to me. So again, these are just different pruning. So this is by the initial angle. This is by the end angle. You can kind of, you know, play with that. Meshing. So meshing is basically the setup of what, you know, some rules for what creates the joints of the mesh, how these joint together, which they're two separate meshes, right? They're not, if we go inside here, you'll see that it's not one mesh. Am I going to eat my words? Let's do this so we can see. We're going to do a blast node, and we're going to blast the trunk. Oh, fascinating. So now it's doing like a cut on the branches. I think that's probably newer than what it used to be. So it's trying at least to kind of help these things feel like, oh, look, there's one. Here we go. There's a there's a branch that somehow didn't pass the test of what it generated. So that one's just stabbed in. That one's just stabbed in. So not everything is always working. And that's the challenge of proceduralism, right? Is trying to catch all the rules that allow us to get that. So okay, so we're going to come back up to the tree control. So again, I usually leave all of that as default. So the Boolean and a normal base blend, great. I don't really play with any of this at all. I just kind of leave it as is. This one might be interesting to play with if you're having troubles with your UVs at these edges. You can kind of blend those two together. So if we were to probably look at this, does it currently have UVs on it? I thought by default it had UVs. It does. Not sure why we're not seeing. Well, normally it will display your UV layout on that object. Sometimes certain things get changed and I lose. Oh well, I'll figure that out later. Back to our tree control. So end caps, whether you want end caps on your branches or not, that's all pretty straightforward. Resolution of our tree has to do with the amount of subdivisions that happen. We'll turn back on this wire shading, and you can see how, you know, as we get to thinner branches, do we need that level of detail, right? So resolution amount is the smaller this number, the tighter those become, I believe, is the. Let's see if I was right. Yes. It's like voxels, right? So you make that number smaller, it's like more voxels. So, right? So you can make something that's really low res. If you're building trees, unless you're doing a post process to kind of make a proxy version or a lower res version, if this is not hero, these defaults are so heavy, right? When you get into the level of tree branching that you need in order to have this, I would always reduce that. And then the divisions. So this is like rows, right? So if we did this at 0.5, right? This is our columns, right? And these are our rows. I don't ever use this refinement amount. Threshold to reduce amount of resolution on straight geometry. So this is like an adaptive, right? So if we probably came back down here to, let's say it's 0.2 and 0.2, which I think were the defaults, something like that, and we just start increasing this. Yeah, so this is like an adaptive sampling, and fascinatingly enough, it looks like it's only on resolution. It has nothing to do with the divisions. And so you can see that way, like if there's not much happening here, well, I don't want that extra resolution. And so it reverts that. And I guess that makes sense that this would just be on the one axis, because if we were to suddenly have here, we have, 30, spans here, 30 faces, and then this next ring suddenly decides it only needs 5, that becomes a mess to try to calculate that geometry. So I understand how that makes sense. Cool. Don't usually use that, but I think that's a great controller to use, great parameter. Now this here, reduced divisions per branch level, means that as we branch out, we get less and less geometry, which is what you want, because if we were to throw another one on here, give that a second to cook, and you can see each level, it gets successively slower and slower. Right, so as we go into these trees, we see, or these branches, we can see that there's less resolution on these, which is great. We don't want the same level of resolution that there is here on these thinner branches. We just don't need it. Okay. So material, this is I don't use any of this. This is just putting attributes on the surface that represent these things. Displacement. That does. Again, I don't ever play with that enable displacement. My guess is it. Oh, fascinating. You can put a displacement texture on there when you turn that on, reduce resolution. So this is if you want to use like a bark texture to drive displacement on your tree branch. Cool. Again, I wouldn't do that in the geometry. I would really do that in the material. But if you have a hero tree that you're super up close to, that can be very useful to be able to generate. So then we have LOD. I don't ever use this. What this offset is, amount of noise through space, start level. I'm curious if this generates like multiple meshes. I don't know what that did. So I don't usually use that. Again, I'll build this out so I get what I want, and then I'll do some things to clean up the geometry and build my LODs. Visualization, you can just see the curves. It's still outputting the mesh, but faster to kind of calculate and look at than going through the whole thing. Okay. The cool thing is once you've done this, like once you've set up a tree that you like, you have this randomize function where you can just change that essentially as a seed value, and you can generate a completely different tree, right? Which is following the same rules, but randomizes the seed values so you get a new tree out of that, which is really helpful when you're trying to make a forest. I honestly will make forests out of just 2 or 3 trees at most and just have them all rotating. But again, I'll have a couple of species of trees. Usually this is what I'll do is I'll have several species of trees, and then I'll usually do a sapling, like a mid-age, and then an old-age tree, and then a dead tree. And so that's usually what I'm doing versus having like 5 versions of this one healthy tree. I'll only have one of this age tree, and then I'll mix in these other ones and I'll rotate them, and you get pretty far with that. I find that I don't usually need to generate a whole bunch of different trees of the same age and type. All right, so now that we've got that down, our controller, the next thing to do is go in and look at these individual things, and you'll see that we have similar controls, right? So if we see we have tropism here, we come onto the trunk, we see we have a general, and then we have tropism, right? Because we can use this to override the settings in our tree controller for this current node, right? So for any of these nodes, I can override what's coming in from the tree controller and have my own settings to drive that. You know, the branch one has, you know, basically all the same stuff, but then there'll be a few other things. So within the branch where we can control placement and other things like that that we don't have in this general controller. The general controller, you see here, we don't have that general tab, so we don't have tree control, so or branch control. That's really on these branches that we do that. So usually what I'm doing is I'm setting everything here, and then I'll control my branch placement, and maybe my really just this tab is the only one that I'm really overriding at this level, which it's not an override that doesn't exist at the controller level. So let's take a look at how we can do this. So I'm first going to just start with our first kind of branch level. In fact, I'm going to start with our trunk. So looking at this, it's great that I have a branch growing straight out of the top, and you probably could do that for, you know, add a point to your, you know, your system here that allows it to kind of shoot one branch up the top. It'd be interesting to do that, but that's not usually what I'm doing. I'm usually, you know, playing with the radius on the trunk here, and I'll, you know, grab this last point here, and I'll just pull it down a little bit until I get, you know, a thinner point at the top. All right. Usually I like that to come all the way. Now, let me back this up. I'm going to take off on noise. I'm going to turn off the mesh noise. I don't really care about that. I find that it does weird things, especially as branches get really thin. It'll cause branches to collapse on themselves and do really weird stuff to the geometry. I don't handle that here. I don't think this is the right place to do that. I will leave the line noise on, because what that does is it creates these variations. For my tree, I don't think there's quite this much variation. They're pretty straight. And so usually what I'll probably do is come in here and turn down the intensity if I'm doing a conifer, you know, what have you. All right, so that starts to become pretty straight. Under my resolution, I'm going to just take that down to something else. In fact, I'm just going to turn that off. So that way I have kind of a uniform system, and I'll deal with the meshing, like controlling that meshing later. Okay, so now let's, you know, again, the trunk is nothing special on these trees. There is on the trunk shape, there is a roots tab that I can come in here, and this gives me these kind of like jutted out roots, and they're cool. You know, you can, you know, change where these things happen. That's pretty linear. Let's change this to something like a B-spline and a B-spline, or not. Bezier. Let's try this. Let's say smooth. Flip it around. Yeah, something like, we'll do it. You can also turn on, so it actually, I believe there's a way to make it generate actual roots, so there might be another node that does like actual roots. I can't remember. I wouldn't use that. You know, I guess if you're worried about your tree showing type thing. So here's the twist. I don't really want it to twist. This is where I'd probably come in and on the trunk, I might turn on some mesh noise, and I'm gonna, let's see here, is it getting greater as it goes up? All right, so you can see here that it's creating like a longer noise pattern. It really kind of decimates when it goes into those roots. It'd be cool if we had separate resolution. Oh, there you go. Get a little bit more. And again, it looks like it's only going to give me, you know, one direction. And I get why. It's not going to add extra spans, but shape offset 0.1. Yeah, you know, something like that. It's fascinating. See, this is where you just get lost in making edits to this stuff. And again, geometry, you know, if you're this far away, who cares about that, right? Like that, it's not a thing. And the reality is this type of tree wouldn't have this much flare at the base, right? So I'd probably come in and kind of do something like that so it doesn't feel so strange. But, you know, overall, I think the radius of this is too thick. Does some weird stuff when you get too thin there. All right, so there you go. So that's, I'm going to call that good. I think, again, I normally wouldn't use some of those settings, but we'll leave them on for now. Why not? What I really care about is once I'm here, we'll leave the meshing what it is. We'll leave the resolution what it is, and that's all great. And from this point on, I'm pretty much done with the trunk. Again, I'll probably find myself having to come back and make adjustments to this, like the tip top of this tree. I'll probably add a point that represents the top of that and you know, give it a direction so it grows a branch out of that. All right, so let's jump into our branch generator. So we have grow and we have place. So I don't really use the grow method on this. It tries to do something that is more physically based, where it's going to say, great, you know, I'm going to follow these rules to, you know, grow a branch. I don't think it works on time. Again, I don't really use it, so I don't. Oh, we got to give it a growth object. So let's try that. So we'll do a tube. This tube, we'll say that's 0. And let's do a transform on this guy and put a null. We'll say growth. And sure. We'll make this 5 and we'll make the scale 2. Something like that. So let's try that. So this growth object now, if we click this little box here, kind of let us pick from where we want to grab. I always like things to be relative. There you go. So yeah. So growth, it gives us kind of an ability to go in and shape something and say, this is exactly what I want you to be. So it's a fascinating kind of way of doing it. Again, I don't usually use it this way, but heck, let's do something new. make you 1. Oh, that's fun. It's interesting how different these two results are going to be. Like, so if we just come back to this, where this is the default, this is our growth, and so this is going to try to grow and follow rules to get there. I'm sure you could do something really cool with this to get it to follow certain things. You know, you come back here to our general tropism and start setting this to get something that makes sense. It'd be fun to experiment with. Again, I don't normally, this is just a starting point. I don't normally use that approach. So I'm gonna go ahead and just put this back to place. So we'll come back to that, test that later. So in placement, you have scatter, and then you have edge length. This has just slightly different results. I don't know the behind the scenes from this. We could probably read what this says. Method for generating branches, super informative. We can randomize, you know, how much it happens, but trees actually are pretty, you know, regular in what they do. So now that we have this, I want to get this so it grows to match what I was seeing in my reference there. So part of this is going to be that as these grow up, these branches are, you know, a lot smaller than these branches, right? Which there's a little bit of that right now in size and thickness, right? The thickness is probably being driven off of the thickness of the trunk, but the length, you know, is not nearly being driven by that as much. So that's our length here. So this is inheriting profile length. What if we do this? Turn you up, what changes? They look to all be the same. That's fascinating. I would expected that to actually do something. All right, so there's this length ramp. So right now it looks like we've got one knot at the very end that kind of gives us a reduction. Okay, so just like any ramp, we can start playing with some of these settings. You know, I'm going to come here and, you know, I find clicking on the actual ramp, it's great, but sometimes I make knots where I don't intend. So if I don't want to add a new knot, I'll usually come down and go to the specific knot that I care about, and I'll just adjust the value. All right, so we can see here already that, you know, now I can kind of start getting to something that feels more appropriate for that general shape. I still don't love it. I think that, you know, when I get up here to the very top, I would expect that to be, you know, really probably 0. Those aren't doing exactly what I want them to do, but all right, so we're gonna make some adjustments here. We're gonna change our branching angle to be 90. And let's do opposite. Let's just take a look. So what this does is, instead of alternating, you know, everywhere there's a branch level, instead of alternating, it's creating a branch directly opposite it. Now the reality is on a lot of these types of trees, you'll get several branches growing out of these nodal points in various directions. So, you know, we could change this to be radial, and then you'll see here we get kind of the same number, right? Branches per node, we get 5. It'd be awesome, you know, to be able to make an adjustment to that. I'm going to change also where we start growing from. Okay. So you can see here there's a change as we're going. There's I think this angle variation. Yeah, there you go. Oh, look at that! It gets super mad. I think I think that angle is the angle, not the. Maybe roll is what we want. Randomize the roll. Again, I'm just trying to get away from this like perfect symmetry. Let's try randomizing branches per node. Did we have that angle variation before? Oh, we do. That's what I'm looking for. It's this guy here. So this angle variation. Nope. Was that the one I was trying before? Yeah, this is making it so we have branches like growing out of the same point. You kind of want like each nodal point to do its rotation, but yeah, we'll leave that where it is. So I'm going to keep it at opposite for right now. For our up vector, I'm going to give it a custom up vector, because what happens is you get these branches are dependent on how these are growing out. It will, it's the up vector isn't necessarily just up. It's based off of a whole host of things. Again, we could go into like how this tool is made, but I just want to quickly blast through this, so we'll start with that. Now, instead of the scatter, I want to try this edge length. You can see there, it gives me maybe a little bit more control over how frequently these grow. Now, one of the things I want to be able to have it be more frequent up towards the top than towards the bottom, right? Because you'll get branches that essentially die off because there's not enough, need for a lower branch as there is for these upper branches, the newer branches, right? There'll be dominant branches that start to take over. So I'm also going to use this distribution ramp to allow me to kind of set where that happens. All right, I paused there for a second because I was getting really strange results, and then I remember after kind of poking around with this, the reason why. So one of the things I did was I came into the master controller, and I turned on this enable phototropism, and the default is its direction is coming in at an angle on the x-axis, right? So it's going to make all the branches want to grow up and in the positive x. So you can see there how they're all kind of growing this way. If the branches were longer, they'd all reach out like this. And so I get rid of I just make it straight up and down. But then it's like, wow, why is this still doing this kind of strange, look? And then I remembered that it's the default on the branches is to have this angle ramp, which is telling it that down here it's wanting to grow along the parent, right? So if we zeroed this out, this first input, if we zeroed this out, I guess this is the top of the tree. These are now growing perfectly out. There's some slight variation on it, but they're for the most part growing right out of it. And then as we get down lower, it's trying to follow the branch. So if we just take this second knot and we reduce it, then we'll see that, oh, look, our branches aren't growing straight out anymore. And so that's more of what I kind of want it to do, but I'm actually going to take these branches and give them a little bit more up towards the top. All right, so they'll follow a little bit more because when they're young, they kind of just grow straight out of or they kind of have a nice upward trajectory. As they get older, they tend to kind of hang under the weight. The weight of the branches pulled it down. All right, so we're starting to get somewhere. This is starting to look a bit like that tree. Now the branches are still ridiculously thick in my opinion. So, you know, we can come in here and there's a radius tab that we can go into, and this radius tab allows us to control the radius of those branches. So now we can just pull that down, and you can see we can kind of shrink these branches down here. Now it's probably too far. Again, you saw grabbing on this. I much prefer just to do this down here. So we'll grab here, and then my second knot here, I'll reduce that even more. Let them really kind of finish out to a nice small point. Now, under placement, I did reduce the length to 0.45. Maybe that was a little much. Maybe we'll keep this at a 0.65. But one thing I don't love is I don't love how high that swings up as it grows. So maybe that's a little long, so 0.55. And now let's go back to our controller and say, great, for this, I really think that our tropism, that phototropism, is maybe too strong. So you can see here, if I set it to 0, the branches just kind of grow straight out, and then as I increase the strength, I get a little more bend here. It looks like, let's make this strong like this, and let's grab that final knot. Yeah, so we can control how much tropism gets applied to kind of the different areas. So in this case, it's not applying really any at these later branches, and it's all really being applied at the earlier branches. Maybe we want to bring that up a little bit on those little short guys, and then on this second one, we're actually going to bring it down. Oh, you know what that is? That's along the branch. That's not along the length of the parent. That's along the branch itself. So you can see here that this is causing that to grow. You know, so more at the tip there. So we're just going to use that overall strength to kind of reduce that and get to a level that feels appropriate. So to me, something like that looks pretty good. Okay. So now I'm actually going to delete these earlier branches here. Let's see, it's trying to generate all that. Okay, so now I'm going to go ahead and I'm going to drop down a branch node, branch generator, hook that up. And we'll take a look at that. So already, right, we decided that we really wanted these branches to grow. Now at this point, off of that main bough grows kind of these, you know, branches that come out. We're going to follow this same kind of idea of the length ramp, right? So if we come here and grab this one here and probably reduce its value a whole bunch. That looks decent. But they're growing out of the wrong way. So we come back up here to our branching pattern, and really it's this 180, and alternating is probably fine. I'm going to use edge length to kind of drive this. Good. But now you'll notice it's kind of twisting around the branch, and this is again why I'm going to use that custom up vector, so I can set exactly what I want that to be, and so there, that's doing what I would expect. I'm going to do kind of the same thing with the thickness that we did before, where this feels a little thick to me, so I'm going to go down to my radius, and on this first input we're just going to reduce this and bring this down. So it feels maybe a little more natural to what I would kind of expect that to get. And there's still some kind of weirdness. And what that is, you see how it doesn't, like there's these weird, like, oh, it's going a kooky way. That's because under the advanced tab, there's this detangle. And what that's trying to do is it's trying to ensure that none of the branches would like grow into each other. So it does some stuff to try to push the branches back out of itself. But I find that I don't ever really need that. It's slower to calculate. It makes it harder to control the output, the way that it looks. But I much prefer to just turn that off and work with this the way it is. Okay. So now we've got that, and now I'm just going to copy this and paste a second one. Connect that up. And now each one of those will have its own little set of branches growing off of it. And in this one, what I'm going to do is go back to placement. Instead of alternating, I'm actually going to do radial. Oh, sorry, not radial, opposite. That's not what I wanted. Hit escape. Uh-oh, made it mad. All right, there we go. So I set it to opposite. So that way each one of these branches is kind of growing on each side of that. And you see we kind of get a cool little result there. I think the overall length of those is probably too long, so I would come down to this one and say, great, your length needs to be 4, 5. Again, I'm going off of just looking at these images of how these kind of trees behave. You know, like what each little thing is, you'll get these kind of little layer. And again, each one of these is different, these type of fir trees. So, but looking for something kind of in this family. We can see that it's pruning off based on a thickness or a length. That's under that prune tab. So if we come back here, up here to the top and go to prune, we can override that pruning and clean that out. Probably need to just reduce this length scale. Both of these placement 90. Again, we're probably on this now, on all of these branches, I really have more resolution than I need. So in this case, I'd come over here and I would override the resolution, which this has more. It's going to suddenly jump up and make a lot more detail on these branches, because I think we were at 2 and 2 for divisions and resolution. Yeah, so I'm going to jump this up to 5. This up to 4. One thing you can see here when I did that is the geometry now is not following the curve. So be aware that this does happen, where this is growing out of the curves that come out of this, but then the geo is there's too much reduction in the geometry. So with this, I probably want to bring back a little bit of resolution here, so we get, this should pop down. All right, that's better. And you can see every time I do that, like the number of branches that grow and generate changes. So we're going to quickly take a look at how we can fix that. All right, looking at this, I'm thinking that it is my length ramp here, most likely, that's causing this. So we're going to come in here and we're just going to increase that on these later branches, because it's reducing those down as it comes out, and we're losing those end branches, is my guess. It could also be that it's a radius thing and it's getting pruned out based on a radius rule. Give this a second. That's definitely better, but we're definitely still culling out, especially up here when it gets to a certain size, we're just losing those as branches, which somewhat is how things would happen in reality. But let's see if we can make this better. All right, so to look, we are generating the branches. This is the fascinating part. We are generating the branches. So you can see here, if we look at the curves, right? So we're making all the curves that we would expect it to make. And for the most part, they look pretty good. So there's a few things here and there that don't work super well. But what we're not getting is we're not getting geometry for every single one of those curves. And that could be that there's a threshold. Again, this tool, you know, it's been a while since I've used it. But if we come up here, let's take a look at our pruning. We're not really pruning anything. This is all by angle. Meshing. This could have to do... end caps, Boolean. That's all turned off. We'll turn that off just in case. That wasn't it. Resolution. It's most likely, no, I bet you it's not that. As this runs, when you make changes, it's fascinating because you'll see that it tells you what it's baking, and as it's baking, it tells you that small parts, there's a small parts delete, which is a node, delete small parts, right? So this is designed to go through and based on area, get rid of certain things. So that is most likely what's culling those out. So when it lives in each side of one of these, and normally those are exposed controls somewhere. So being that they haven't given us the ability under meshing, they really haven't given us the ability to go in and turn that off. If we dive in here, we can see this is what's going on under the hood. This node is a node that you could build, and you can see why, you know, when you build a custom tree generator, a lot goes into it. So we could come in here and try to find that node, which is delete small parts. I'm guessing it's somewhere towards the bottom here. So we'd have to go in and like unlock this, go in and manually change that. But I'm curious. I want to try to find it. And we'll take a look at what it's doing. All right, so I used in the node graph here Control F, right? So if we hit Control F, it might even just be F, maybe. I don't know. It's the little icon glasses here. Find node. So I typed in small, and then you could select these. It'll take you to it, and it's built in, and there's nothing that's kind of setting when this will happen and when this won't. So I just pulled back a little bit to see where it's happening, and it is in this Boolean normal blending kind of section here. So let's, with these little branches, let's come in here and, right, because we're not losing any big branches, it looks, oh, we are most definitely losing some of our big branches too. So with all three of these, I'm just going to go ahead and tell it, actually, let's just do it on the controller. Under meshing, let's just say none on the intersection behavior. We'll just let those kind of stuff into each other. And look, just by doing that, look, there they all are. So we've now got all of our branches. Everything's doing what we want it to do. Woohoo. Some of these are really skinny. Really tiny branches. But when we look at this is starting to kind of feel like a tree overall, which is great. Now we can come in and with this branch generator, let's take our general placement and maybe let's just move this down just a little bit, get a little more out of the tree. Yeah, maybe not quite that much. Let's make this 275. And then now the next thing I want to do with this is two things. I think that those branches feel a little bit ridiculously thick. So we're going to come in here and just reduce this a little bit more. And then this last point, we'll keep it a little bit thicker there. So we have a little more at the top, right, of a decent branch. And then at the bottom, let that fill in. So that's great. It's very CG right now, which is okay. I'm a little okay with that. So we're going to call this good for now. The cool thing is looking at this, I could add more branches to this one generator, or I could come in and say, great, I'm going to, off of this second generator, let's just make a variation. Like, not every branch is going to be so big. So we could come in here and we could reduce this length, right? So let's make this 0.8, 0.6. So we get more branches in here. Let's reduce the phototropism, right? So we're going to enable this. So we still have a little bit. And I'm going to go into my radius, and I'm just going to reduce my radius even a little bit more. So these are kind of like young, branches that maybe started out later than those other branches did. And then placement, let's change their length. Let's reduce this just a little bit. So something like that. And then I want to, we'll just kind of bring this around, something like that. Well, this is the branching angle off the side of the tree, maybe? That's exactly what that is. That's a weird. We'll leave that at 0. Did I have that on here? If I did, we're turning that off. I did. We're going to turn that off. So with this, all right. So when we insert this into the chain, that did some weird stuff. I'm not sure why that's so angry. Well, whatever this labs progressive resample node is unhappy. There's just a bunch of unhappy stuff here. All right, I have no idea why this is mad right now. It shouldn't be. It's a branch generator. It should work just fine. It seems to remember. It seems to remember who it was told to grow from, and it's like, I'm not growing from branches. So here, this was the next step anyway. But one of the things is, if this, in theory, should be doing these rules off of these branches, but we want this to be growing off of our trunk. So you could put these next to each other like this, and then do a merge, right? And you would merge, have two merges. Right, so this gives us all of our geometry, and then this gives us our wires, and then you could plug these in to here, and then you would get the next level growing. So that's one way that you could do that. I don't like that. It's messy and it's extra. So I'm just going to do this and see if that, oh, see it's still angry. And so what I'm going to do is I'm going to tell it exactly what level I want this to grow off of. I want this to grow off of our tree trunk generator. So I'm going to tell it that. And you see now the error goes away. I don't know why that node seems to have a memory, but it did. So now, there you go, you can see that we've got kind of our two sets of branches, and it gives me just the ability to have a little bit more fine-tuning control. I can vary those based on slightly different rules. Now, in theory, you could go in and with the ramp do this kind of idea as well, but I find that it's very easy to do this. So then once you've done that, the next level will grow branches off of just this input, right? So now it's only growing our secondary branches off of, oh, look at that, we've got intersecting branches, how fun. It'll only grow those branches off of the group that it's coming from. So this next level branch, I now want to tell it that I want it to grow from our branch generator 1 and our branch generator 4. So now it will grow from both sets of branches, and I've got to fix that nonsense. So I'm going to take branch generator 4 and I'm just going to randomize it, and it should pop those branches out. It did not. Did not even randomize it. Well, that's fun. I love it when tools don't do what they're supposed to be doing. So there you go. That should have changed something, but it didn't, so we could go in and just, we'll take this length ramp here and this one here, and let's just move it a little bit. And there, now we're offset enough that I wouldn't expect things to land right on top of each other. We're getting close. We are super close on a few of those, but that's okay. I think it's passable. I'm happy enough with that. So now let's go back. We can see that we're generating our sub branches off of both those scale of trees, right? We can see it's happening off of both of them. You might make another branch generator that just generates off of these. That's slightly different, right? Maybe it's got different edge length. It's up to you. You really can kind of customize and mix and match to whatever makes the most sense. So, and now we've got kind of our full length. So I'm going to come back to all of these. I think all of these branches to me feel a little ridiculously thick. So let's come back to generator 1, radius. Oh, let's try it here. We're just going to come up to the main. Do I have a general control? I don't. How sad. But if I start on generator 1 and I reduce its radius, there's a general adjustment that you can do. Like you can just push this down. But one of the things I find when you do that at the top of the tree, it can get ridiculously thin. We'll do it just a little bit here so you can kind of see. It's gonna, I feel like stuff is not updating. Oh, it is. So there you go, there's some really skinny branches. Really skinny branches, but that's too much. So let's just do 2.5. That's still a little thick. 0.5. Yeah, that works. And I'm going to come back into my trunk generator here, and I'm going to move this knot out just a little bit. Add one. Ooh. Add one more. And we're going to make this 0.1 that thinner. Yeah, something like that. That's more of what I would expect. Now those branches are getting awful thin at the top. That's because really this prune, or this radius that we're using, this offset, again, I don't really like that. It affects the tops too much, so usually I'm gonna adjust the ramp instead. I think that gives a better result. Okay, so now we've got a tree the beginnings of a tree. What does every tree have on it? Every tree is going to have, well, it's going to have leaves, or in this case, needles, which are just a different type of leaf. Let's lengthen those out. And the reality is there would actually probably be one more set on here. So let's do this. Watch. Length scale 2. And let's change how much the angle ramp on this is. We're going to take our, oops, that's not what I meant to do. Oh my goodness, you're seeing me have a moment here. What in the world just happened? All right, you missed it, but my Houdini session crashed. I lost some stuff, so I'm kind of rebuilding a little bit here to get caught back up. But it's interesting. There are certain features that will just error. For example, here's our kind of distributed tree branches that we've got on here that we're feeling is looking okay. And my thought was to, well, let me see if I can make it so we have more branches down towards the end and maybe less towards the interior, and use this same distribution ramp that we're currently using on this generation of branches as they grow up, in order to allow those distribution to do the same thing. So as it gets closer to the top, you get more density when they're thinner, smaller branches, and so it'll help kind of keep the top of the tree filled out. And then down here, you need less. When you turn that on, it immediately errors. I'm curious if I give it an override as to the branch. Is that gonna, no, so it still doesn't like it. I'm assuming that there's some, combination of a control that I need to hit in order to allow that, but we'll just turn this off for now. I lost my second set that I had going there. I'm going to take this one here, and I'm just going to reduce this a little bit. I don't need quite that many. What I was trying to play with was the angle ramp, right, which is what causes us to point down the branch. So if we do this, you'll see that it just kind of spreads out evenly and doesn't want to point down so much, which is really kind of nice. I don't think all of these point down that branch so much, and it allows it to kind of fill in just a little bit more, so you get kind of these bigger umbrella boughs, if you will. So now that I've got that set up, again, I'm going to go back and I'm just going to copy this one here, paste a second one, and I'm going to make some variations to this so we get us back to where we were. Perfect. Length, we'll make this 0.5. We'll take this and our radius. Oh, that's not the right thing. And again, this is one where if I now plug this in, it's going to get really angry, right? And we had to tell this that expressly that we wanted this to grow off of the tree trunk generator, and now that goes ahead and generates, which is great. I still want this to be a little shorter than that, even. Let's put 4. Nope, sorry. 4.5 was good. Maybe 4.5. And then we'll take this and make this 0.1, so we get a few more of these. Maybe we'll make it 0.8. Or maybe we'll go crazy. 0.6, so it's kind of every other. Now, this next one, we have to tell it that we want it to grow off of both. We can tell it to do both those, or we can just say all branches, and it'll catch all the branches before it. So that's probably even easier than what I was doing before. So now we look at this and suddenly it's like, okay, this is starting to become a thing that feels maybe like the tree that we're trying to get. I think this first branch is probably a little long. Just looking at the overall shape. 4, 5, that's probably something like that. Okay, so once we're here and we've got kind of a general shape, what's next? What's the next part? Well, you know, the thing that makes any tree look like a tree is its leaves. So the next node in this, if we look at leaf, is there's a simple leaf and a leaf generator. So let's look at the leaf generator and let's look at the leaf simple. Leaf simple is just that. It's a card that is a leaf shape. So our leaf requires an input, and you could give it this leaf as your leaf. So before we do that, let's just take our leaf generator and let's plug in our geometry and our curves, and let's see what we get. We don't need this anymore. Currently, I'm sure it's doing some pruning, accurate leaf placement. We'll turn that off. And let's give it a leaf. Haha! Look at that. Let's turn back on that accurate leaf placement. So it didn't really change anything. We're clearly, I'm sure there's some type of detangle in here somewhere. So, you know, we're losing it up here because it's feeling that it's too close to put our leaves in there. So I don't know if that's a... This is the fun of tools changing. I look back at an old setup that I had that was using this, and I get very different results. And I was noticing that before, it used to be that I didn't even give this a leaf. There was a system inside that would generate a leaf for you. They've done away with that, and now you have to give it a leaf. So in this case, you know, if we take a look at this leaf, it's pointing probably in the z-axis. It is. I mean, that thing's huge. It's like 1 meter long. So, you know, we could take a card, right, or a grid, and so that way we have total control over, you know, the size of this. You know, you can see this is 14 polys. So if we take this and maybe do it we'll make this 1 by 1, and we'll make this 3 by 3. So we should now have 9 polygons, right, instead of 4 polygons if this was 4 by 4. Then we'll have 9 polygons. And then we can, you know, we can do like a bend on it or something like that. I'll take this and transform it. And Z, so this was 1, so we'll do 0.5. All right, so that puts it on the edge there. That's great. And then we're going to do a bend. It's capture direction on this. Up vector is 1. Capture direction is 1. That's great. 1. And now we just bend this. So we'll do a little bend like that. I think before that one, we're going to do a similar bend, but we're going to do it in the x-axis, the capture. And there's a way to set this to mirror, deform in both directions. So now we get kind of this, you know, droopy kind of leaf card thing, which is great. That's a lot less polys than what this was. So we'll hook that on, let that generate, and we'll see, okay, now we've got all these leaf cards, which is nice, but we're still not getting the whole thing, which is a little strange. I may have to dig into this a little bit. I am guessing part of this is how it's growing. Right now we're just growing from those last set of branches, right? This branch 3, which is really, you know, just a small set. So I'm going to tell this I want it to grow from all branches, and let's see if we get better results. We do. I'm still a little concerned that it doesn't want to grow out of my my smaller branches in some of those areas, but we'll take that for now. So this becomes our tree. We now got a bunch of leaves on there, and we can see, just like pine needles, they kind of grow in all directions, and you know, you could go in and make that adjustment. So the next step from this is to now put shaders on this. All right, so for rendering this, we're going to be rendering this in Solaris, so we want to move this into that context. So currently we're working the object context. So I'm just going to put down an output node. We'll output this as mesh. And we're gonna do a whole bunch of stuff to this to kind of get this ready for going into a full-blown asset. So now we jump over to the stage, and I'm going to go ahead and put down a component builder. And this is Houdini's little kind of mini pipeline for working on assets. It works pretty nice. So if you're just kind of doing it on your own, it's a great way to kind of build stuff out. It'll take all the textures and pull it into the local directory. It's great. So like if we're pulling stuff from Unreal sorry, Megascans or anywhere else, any type of stock library, it'll pull this in, so it's all encapsulated into one save location, which is nice. All right, so I'm going to use an object merge, and I'm just going to start out by pulling in that mesh. So we'll come out here to our fir tree, and we'll grab that output mesh and pull that in, and then I'm going to just plug that in right into my my setup here. All right, so with this, we can do a host of things here of trying to get this to display. We want something that's a proxy, that's low res for us to look at. So I'm going to pop back into my tree itself. So I'll go back into the object network here, and I'm just going to put another output, and I'm going to call this wire. And then I'm going to bring in an object merge for that wire. And now I'm going to plug this in as my proxy. Oh, why are you mad? Oh, yeah. When I put down that extra, I need to give it its own index. So now that'll be fine. It's going to calculate a bunch of stuff. There we go. So now we can jump back over to the stage. We can jump into our, I'm going to go ahead and pin this here. So you can see already, here is the way it's drawing that. And it's because it doesn't have p-scale on it, so it's putting a p-scale value of 1. And so that's what's giving us kind of this look, which is really cool. What I'll usually do, just for visualization purposes, I'll come in, I'll put a color node on here, and I'll set that group. I've got all these different group levels, so I'll use, you know, like the trunk, and we'll make this brown. Right. Actually, I'll probably do that. I'll make everything. Oh, no. Let's do the trunk brown. Let's do this. We'll do everything green, and then we'll do a separate color, and we'll just do the trunk brown. And that's a real green. All right. So we'll come here and we'll say trunk generator 1, and we'll make this a nice brown color. Something like that. I'm gonna modify this green a little bit. That's a little too green for me. All right, something like that. So there you go. So now when we scatter this is what it's going to look like, and it will give us this, you know, nice low cost display. If we look at this as to its number of points, right? It's 8,000 points. Where on the tree itself, we're looking at almost 1 million points. So that's a huge savings in draw memory. So it makes it really helpful to be able to kind of lay that out. So, all right, so that's now we need to build a material. I'm not going to go through making a material for this. We've kind of, well, let me just grab. Sorry, I'm going to step over to another. Okay, so again, Quixel Bridge is a great place to grab, to get an idea of what you're looking for, because there's this idea of atlases, right, which are actually really useful when we come over here and do like tree. And we can see we've got all these different atlases set up, so we can use these for our leaves as we pull those in and texture our setup here. I've used this here, this spruce. The thing with doing this is you kind of need to set these up using they have an atlas splitter that will break these up into individual cards and UV them out and do proper things. So we can look at that. So let's do that. Let's take this here and we'll open our Megascans plugin. We'll go ahead and use the atlas splitter. We'll leave this all as it is default. And come back to our bridge, and let's use this one here. So all right, so I believe, oh, we don't have that downloaded, so do I have it at 2K? I have it at 2K, which honestly, I'm not getting close enough. I don't need the 4K resolution, so I'm just going to use that 2K, and we'll export that out to Houdini. All right, there it's sending out, doing the conversion of textures to RAT, successfully exported. So now the other thing I want to go grab is I'm going to grab under surfaces. There's like a bark, and so we have all these different, types of barks. We have pine, tree bark, spruce bark, and really, unless you want to get really particular, you can kind of go with whatever makes most sense to you. So let's use, I'm going to go ahead and use this maritime bark, and so 2K resolution's great. I'm going to make sure that's downloaded, and then we'll send that over to Houdini as well. All right, so we can see here that this maritime pine bark showed up over here. If we go to our object context, you'll see that we have this plant perennials. This is that atlas that we generated, and we can see here when we take a look at this. It made these little cards for each one of our pieces. Right, so we now have various pieces that we can utilize as our pine needles. All right, so let's pull these in and start using these, because what we've set up right now is we have these cards that are our pine needles, and we're going to swap them out for these, because what matters with this is if we take a look at our UVs for this object, we can see that this is mapped to where those individual pieces exist on the texture map, right? Which is really fancy, really cool. I haven't played with these much. Let's take a look at. So I'm not really sure what the sorting does. Treat as leaf is going to keep the anchor point at 0, and then distribute just allows you to see them. This to me is not very useful when it comes to actually using these pieces. We can either just use one, or we can load in these 5 different pieces, 6 different pieces, and randomize those on our object. So, and then you can put a bend on them if you want. So there's some bend controls there to do something like that. We'll leave that as it is. So we're going to just kind of leave it as default. And I'm actually going to take this and I'm going to put a merge down. And I'm just going to take all of these. Oh, wrong hotkey. Put an output node here. Out all. And now we're going to come back into our fur, and we'll come up here where we used a grid, right? So this was our grid that we generated. Now we're going to use an object merge, and we're going to pull in that perennial plants out all. And let's just take a look. So there's our difference there between the two. So we'll switch that over. Take a look at our leaf gen. All right, so there it generated, it put those on. Now, it took a long time, and I remembered because as you look at this, we have a treat as Atlas. Or use as variant. Pack an instance is also good as well because what it does is it uses just a single instance of that leaf, where this is using actual leaf geometry. So if we take a look at this, this is going to be quite a bit of data. You know, we can see here how much my RAM is, you know, it's jumped way up. So, and there you go, because it's 14 million polygons. That's a lot. That's a lot. So we're going to pack an instance, and that should make it go through a lot faster, which it did. And then we are still currently putting all of those pieces on every point. So I'm going to try this use variant, and that's funny. It's doing something strange. This is probably looking for a very specific attribute. I'm not, you know, I'm trying to remember the last time I did this and how I broke that up. All right, so turning on the treat as Atlas just ran forever. So what it looks like when I dive in here and take a look, you know, you kind of can go through their tool. And here's where it's using this variant attribute, and it's creating this variant max. It's creating, it's promoting this original name, which is variant, to be variant max, and its promotion method is maximum. So we're going to try this. We're going to put, because if we look here, we don't have a variant attribute on our object, but we do have name, so we have 6 unique names. We also could probably do a connectivity attribute. I don't know if it's looking for a number or a string here. So if we look at our geometry spreadsheet, we can see that we have these named pieces. So let's just do this at first. Let's do an attribute create, and we'll call this, name of this is going to be variant, because that's what it's looking for. And it's going to be on the primitives, and instead of a float, it's going to be a string. And for the string, we're just going to say @name, and so we need to put it in little ticks. And so now it's just copying that over. So that way we're not wrecking our name attribute. Now let's take a look at what that does and see if that didn't change anything. So we now have a variant attribute that it didn't have before. Let's dive in there one more time and take a look at this. It's taking this from a point. It's looking at a point attribute, not a primitive. So I think what we're going to do is we're going to then say an attribute promote, and we're going to take from our original class, which is a primitive, our variant, and we'll promote it to a point. And it still didn't like that. So the next thing that I'm going to do is, instead of making this, creating this attribute in this way, I'm going to use a connectivity, because this is going to give me an integer value instead of a string value. And instead of class, we're going to call this variant. Instead of point, it's going to be primitive. We probably could do that. We probably could do that off of the point. Let's see what we get. Let's look at this. How many? Let's see here, variant. And go to our geometry spreadsheet and we look at variant. Yeah, okay. So we could just bypass this part. Okay, let's go back to our tree. Aha, and there we go. So often with tools, when it's not doing the thing that you're expecting, you kind of have to dive in and find what is it that it's looking for when I do these different things. So here we're telling it to use this variant, and now we're getting appropriate variants on each piece. So if we click this off, you'll see that we get kind of more because it's stacking everything on one. But if we say use variant, we get just one card per thing. Now, pulling back, this tree feels pretty sparse. I would think that I would want to put more of my leaves on there. So I would probably come in here and my leaf node, reduce that to try to fill this in more, maybe even more, something like this. And we probably just don't have enough branches either to kind of fill this up and make this look good. But we'll start with that. So now we've got leaves that are doing the proper thing, and now we're going to go back to our, we're going to use our back button here. We'll go back into our object area. Let's see, and let's go into this perennials. We'll go up one, and we have a material already all set up. Now we're not going to use this material because we want to use material X, so we can use this in Karma XPU. But so we'll go back out to the stage here, and we're pulling in our tree into the stage, and now let's go ahead and throw this on as a shader. And now it's pretty quick and simple to set this up. All we're going to do is look at the textures that exist in this shader, and we're going to make file reads for those and plug them into the corresponding parts of the shader that we need for material X. All right, well, this is why we this is why we've switched to this video format for our lectures instead of doing this live in class. I kept getting crashes here and was trying to figure out why as I brought in this mesh. And I'm suspecting that it has to do with the leaves being packed and instanced. So packing and instancing, when we look at this, gives us this setup where we have our points, and then we have these packed geos, right? So we basically have 250,000 shy a few leaf geometries that are packed on there. I think that's what's messing things up, that when it goes into USD has its own way of figuring out instancing, and I think that may be choking going through this component builder. Not certain, but I'm going to turn off the pack and instance here, and when that builds our mesh, I'm guessing that's going to give us, it's going to be way heavier in that there's a bunch of geometry there, more polygons. But if we were to do this another way, we would output for each leaf a point with its attributes, for rotation, and then we would make an asset for each leaf, and then we would create an instancer of that onto those leaves, onto the tree itself. Now, having done this at a few studios, or just recently, we built out a forest, and we were doing that. We were instancing the leaves onto trees and then instancing the trees in the forest, and we actually found that it was a performance hit to have that level of nested instancing. It can do it. It just didn't save us what we thought it was going to save us. It just made for a lot of extra overhead in the USD and how it was pulling things. It preferred to just have the whole tree, which The problem with that is then this takes more RAM in memory, right? You know, if we were to take a look at this, you know, and what are we using? I'm at 71 gigs of RAM. Now I have a couple other Houdini sessions that are currently open that are consuming stuff, so we can take a look here. It's not that one. It's probably this one right here. Yeah, so this is this session, but you can see that, I mean, this is by far using the most memory. So don't love it, but I think that that's what's causing this to crash. So we're going to check that out. We're going to see right now. We're going to come back out to our stage, and we're going to plug that in and let that rock and roll. And then we're going to jump out here to our stage. Cool, so there's our tree. So in looking at this, we've got a tree here. I'm going to hit save just because it's good habits. And I'm going to actually switch over to our XPU. And so you can see that we were using that the wires as our display, but now when it does our render, this is going to kick over and use our actual geometry. All right, cool. So we can see here that we're only getting our leaves. And that most likely has to do, so maybe instancing isn't the problem, maybe it's just a naming issue. So let's take a look at this. Let's dig in. I'm going to switch over to my Solaris desktop. Okay, so we can take a look inside of here, our geo, our proxy, is that wire shape, and then we have these different pieces that are coming in, and these are the name attributes that exist on our different leaf pieces, and that's why these are getting generated. So we need to go through and add some information here to help this come in and build a proper composition here. So it's basically it doesn't have enough information of what it's trying to do. So let's help this out. So we're going to go ahead and jump back over to our actual fir tree. We can do it here, we can do it in the component builder. Let's do it here so we're just kind of building in one place. So what I'm going to do is I'm going to put down a name from groups. That's what we're going to do. Now, looking at what we have in the form of groups is we have a whole bunch of stuff, right? So we have, come down to our group, we have all branches, branch caps, leaf, level 0, level 1, level 2, level 3, level 4, manual prune, previous level, right? Tree branch generator. So I'm going to use these generators because it's going to give me the whole thing. I don't want the trunks, caps, and things like that to be on the caps to be on their own thing. So let's try this with just using this generator. And so what we're going to do is we're going to come here and let's look at the naming on that. So they're all generator with a number at the end. So let's, for our group mask, let's say star generator star. And then we'll take a look here. And let's actually do this before we go into the leaf generator, because you know that was generating proper pieces there. So let's just see what we're getting here. So there we go. So now it's creating a name attribute that we didn't have before, and it's giving it based on that name generator. Now I don't love this. This is, to me, is just it's taking it off of these right here, right? So tree trunk 1. So we could rename these nodes, and then it'll clean that up. So instead of tree trunk generator, let's call this, we'll call this trunk gen, and then we'll call this branch 1 gen, branch 2 gen, branch 3 gen, branch for gen. And now we got to fix this, right? So we'll do, for our group mask, we'll just do underscore gen, and that'll capture all that now, and we'll move that name over. Now we can strip off that gen. Let's see, we can do a rename. No, don't want that. Really what I would do at this point is I would use a little vex to come in and just clean up this naming. We'll leave it for now. That's clean enough. I'm going to pass this in to our leaf generator here. I want to come back here, and on this name, instead of piece 0, what I'd like to name these is, I'd like to give these a name attribute. So we'll just say name attribute. We'll do attribute rename, group rename, name from groups. This is one that I would have to do. So I just don't like piece, right? So what we're going to do is we're going to do this. We're going to say an attribute wrangle, and we'll do just a little wrangle here. This is the power of being able to do this, right? We're not there yet for a lot of us who are new. Don't be afraid of wrangles. It's about doing simple things, little passes, little work pieces. So here we're going to say, let's do this. Let's say, we're going to say, I keep saying that, blah, blah, blah. What are my words? So we want to take our name attribute and we want to strip that out. So we're going to create a string, and we'll call this name elem. Doesn't really matter. I'm defining that. I get to come up. I can call it whatever I want, and I'm going to just put these box brackets after it, because this is what we're doing. Is we're going to split this where we give it a string. In this case, it's going to be, we'll say S, so it knows that we're giving it a string attribute at name, because that's what exists down here, right? This name, and it's a string, right? String being words. And then we're going to tell it what we want to split by, and we're going to split by that. Oh, this is not the right thing. Let's do. Let's try this. Actually, we're going to do another connectivity. We did this based on points, and we created a variant. We're going to do this now based off of primitives, and we'll just call this name, and type is going to be string. And we will call this leaf for its prefix, like this, and there we go. Way easier. So that just replaced that, gives us just a little bit, something a little cleaner. So now that this is all plugged in, when we come back out to our stage, give this a second to finish building the tree. Ideally, we cache all this stuff, so once it's done, we're not having to jump through these hoops. We can see that we've lost our color that we had assigned. It just assigned it all to one. I'm guessing that's because our proxy is just this singular, and so it's not giving us a color per point, which is a little sad. So there's this far as color, but it's not using it as display color, which is a. But now when we come under render, we see we have different levels of branches, right? We have our leaves, and oh, we didn't catch our trunk. So let's go back and look at what happened with our trunk. We lost branch 2 as well. We only got a handful of those, so let's go look at what's happening. So we're gonna go back to our fur. When it comes out of here, oh, our trunk lost its name. because it's became a tag. Fascinating. We have a tag over here, no tag here. This should be generating tags on all of these. Very strange. We might have broken a few things here, as we've told it this to run on tree trunk generator, right? But that doesn't exist anymore. So we need to change this to be trunk gen, right? That's probably why this stuff disappeared, right? That's exactly why this disappeared. So this branch 2 went away because it was based off of a name that we changed, and then that didn't update. So now we should end up that we have, with this selected, we should have all of our branches, and our trunk still isn't. We must not be getting a group. So we get a group trunk, not trunk gen. So there's an easy way around this. The other thing that we can do is we can create, instead of this group name from grouping, we could also do attribute. I don't know what the right node for this is, because I always would just do this with a wrangle. Attribute from pieces, from volume, from parameters, attribute mirror noise. Probably a rename, an attribute rename, so long as it doesn't delete the name that it comes from. So let's find an attribute, noise, promote, remap, rename, and override existing attributes, encode invalid. Yeah, see, this is going to delete the existing attribute, right? So if we went like this and we said tag and we change it to name, and then when we take a look at this, there's our name, but you'll see we no longer have our tag, right? So our tag is gone. Or if we select here, there's that tag. Maybe we're okay with that. Let's tell it to keep the tag. It doesn't seem to like that. The reality is we're not going to use that attribute, so it's probably fine to delete that. Now, I wouldn't do it until after this, because that tag is like if we're trying to insert anything in the middle of this chain, I would want to make sure that I'm not modifying that till after this leaf node. So let's do that there. All right, so we're just going to pop that off, pop it in here. And now, oh, look at that. We still don't get a proper name attribute for that trunk. Unless did that just update? It did, it just updated. So leaf, everything's got a name. Nope. Our trunk does not like that. Where are all our branches also? Oh, we don't have a tag attribute on our branches. That's right. It was giving us something strange. My goodness. Okay. All right. So I'm going to delete this. I'm going to say, and my goodness, attribute from group. Oh, there was a name from group, right? Which is really, it's a similar node that you could do this same thing, right? Where we could take this and go grab these attributes and say, based on these, give me this. The cool thing this is just going to give you a 0 or 1. It'll give you, attribute name and then the value. The cool thing about this is it takes a group name and it creates a name attribute out of the group name. So in this case, we're going to go back and say underscore gen, and we'll call that name. And then we'll just do a second one, and we'll and the group was trunk, right? That's why I didn't capture this. It calls it trunk automatically instead of trunk gen. It's fascinating, the inconsistencies, and again, this is a tool made by artists that work at side effects. That's part of the side effects lab. So we'll just call this trunk, and I would hope that that's going to give me then see, then there's that trunk gen right there. But look, it's zeroed out. There's nothing in it. It doesn't read as anything being in trunk gen or really anything being in trunk. So here's what we're going to do. We're going to do attribute name. I'll just do name like this. All right, so everything right now has a name. So we get past trunk, I believe, and get into branches. We should start seeing, there's tree leaf. So here are our branches, right? Because they didn't have, oh, now they're not generating a proper name. Oh, because I need a star. Isn't that fun? All right, there we go. Branch gen 1. So clearly that can't just be hard-coded to one thing. So I wonder, this is just about thinking through problems, right? So we'll take this piece here, and we'll say star trunk, because I don't want to catch the stuff that was yeah, it didn't let me trick it like that. That's a shame. Okay, cool, no problem. All right, last thing I'm going to do here before going to a wrangle, because I'm trying to do this with nodes, is I'm going to take an based on a group, right? I can use these groups that exist. So I'm going to say trunk. The attribute is name, and I'm going to call it trunk. And instead of that, I'm going to do this and say trunk gen. Let's come up here and look at the trunk as it comes off here. So we have a tag, trunk gen, and we have this group, trunk gen cap, and trunk. So it looks like it is not capturing anything in that actual group. So if we come up here, so let's visualize this. We're going to grab our picker. We're going to tell it to select geometry groups, and we have level 0, nothing in that. Trunk, nothing in that. Trunk cap, which is that very top piece. Trunk gen, nothing, not in group. So there's something amiss inside of their tool that's not grouping this particular one properly. So here's what we're going to do. We're going to come in and say group. And what I'm going to do is I'm going to take this tag, right? So this, results in trunk gen, and I'm going to copy this parameter, and I'm going to come into this group, and I'm going to paste relative reference. The reason I did that is because then if I rename this node, this group will propagate properly. It'll fill in properly. So now there in trunk gen is all of that. If we come down here now, and this very first one, we should be able to select this. Okay, so now when we come in here, we see we have all these different, a million groups that we really don't need. There's our trunk gen. We have an all branches group. We really should, now let's do this. Let's select based on name attribute, and we'll see that we have our different leaves that we've got. Leaf 1, 2, 3, 4, 5, 6. Trunk gen. We have branch gen, branch gen, branch gen, branch gen. So success. So I'm going to plug this in. We'll get rid of this. We don't need that. I'm going to hit save because I've had a couple of crashes, which are super fun. And now we're going to go back to our stage and we want to take a look at what this output looks like inside of the USD structure. And this is where it gets challenging of working in USD inside of Houdini, because in Houdini we're used to just like, well, it generated, it's in the viewport, I've got the data I need, this should work. USD comes down to how is that data structured, becomes a very important thing. All right. So now we should be able to look at our composition, and there you go. We have our trunk gen, we have our branches, we have our leaves. So now we're fully in here. I'm going to hit save, and I'm going to switch this to Karma XPU, and let's take a look at what our render looks like. Awesome. So there we go. About a 5-second render. You know, there's a little bit of queue up time, and so there we go. We've got our tree with our cards on it. This is great. All right, so I think we're going to call it right there, and we're going to divide this into a two-part because there's a whole lot more that we want to do to these trees. So we want to get into levels of detail. We're going to convert that cluster of pine needles of leaves into like a leaf bag that we're going to texture and shade a little bit differently. We're going to put snow on it so we can have a snow variant. And we're going to do a few things that way we can really kind of push when we're building these assets, what's the flexibility of building in as much into these as we can so that we can then use that in our scatter system and get into that. So there's still some more to build. We'll cover putting on materials. That's pretty straightforward. We've done that already. It doesn't require the same level of build that our terrain materials require. We don't have to go in and use a bunch of attributes to try to mix and match textures. Is just pretty straightforward. We're going to slap on our pine needle texture, we're going to slap on our bark texture, and off we go. The one thing is we'll have a third material in there that is going to be our material for our leaf bag variant that's going to be different. We're going to cheat that a little bit. So I hope this has been informative. Catch you next time. Thanks for watching.